Welcome to Inside Builder channel. Can you tell me about LLM agents? Executing series of tasks in loop until completing the final objective. That's what agents do. And in this discussion, we are going to dive into how a simple agent can take a task or an objective and try to work with various prompts, plan the steps, execute the steps, and then generate code. We are going to see all these things in action in a couple of minutes. But before that, let me give you a heads up on the various other supporting roles and discussions that I have around this video. It started all with telling about the basics of LLM agents and agentic software. You can see that video, and then you can also look into the way Jinja template engine works with creating prompts and powering up the agents, and finally how the prompts along with programming logic solve the tasks. So all these things all these videos will be a kind of a starting point or a prerequisite for this particular discussion, because here we are going to try and work with a simple agent that does all the activity together, but it is going to do it step by step, so you can see what happens and how it works in the backend, how the agents like the Crew AI, the GPT-Pilot, Devika AI, AutoDev, Devin, all those agentic softwares in the backend have a way to power up the prompts and then send them to the large language model, the API endpoints, and then get the data back. I mean the replies or the responses back, and process it again so that it can be used for completing the tasks at hand. So we are going to break out of all the additional code that is in place in these softwares, so that you can directly look at the raw code, that the raw agent code that interacts with the API endpoints, that is LLM API endpoints, and gets the things done. So without further ado, let's dive into the process that we are planning. So the process is pretty simple. So the simple agent will be called and the objective will be given. So let's see how this works. So let's go to this particular command prompt path is the Python DE learners data GitHub repo path. This repo will be shared with you guys in the description, so stay tuned to try this out. This is a very simple agent. It does not have a lot of control mechanisms to avoid wrong outputs. It does not have all those checkings that all the other agentic softwares have. It's merely a simple logic oriented while loop powered agent. So let's start. I'm going to use the Python simple agent demo.py script. This script I'll be explaining after I complete the demo. So it starts with asking the task, and before I give the task that I want to complete, I need to give the file that it is going to use to save the tasks. So I'm going to use the task list JSON, but I'm going to say task is demo.json, because this is going to be with respect to the demo that I'm running right now. So provide the app type. So I'm going to say it's Streamlit app, and the app name CSV data analyst is the app name. It's going to analyze the CSV files. The app takes a CSV file as upload, and then reads the CSV file and renders the data as data frame. Following that, the CSV file is analyzed, and data visuals like bar chart, line chart, scatter plot are created. That's it. This is what I want this application to do. And I've given this information and I've pressed enter right now. The moment I pressed enter, the request along with the app, along with the name of the app, the type of the app, and the prompt has been sent to the it has been sent to the OpenAI through the agent API endpoint. So now it has taken 795 tokens and it has already created the tasks. The tasks are already saved in the task list demo.json. So let me show you the task in the command line itself. So we have the tasks here. Since the command line rendering was not that good, so I had to open it in the VS Code itself. So this is the tasks that has been created right now. As the next step, the agent is going to classify the tasks. So I'm going to execute classify the tasks, and in order to save this task, I'm going to use a file called as task class demo.json. So this is where the file is going to save, and what it's going to do is, you see, it is going to take each and every task that it has found in the earlier step, and it is now classifying it. It is classifying it into code generation, clarification request, decision making, and planning into various types of tasks. It's trying to classify first, and for each of the tasks, it's actually telling me how many tokens it is actually using that. And further, after this, it's actually saying whether you have any more questions to ask. If I say no, it will actually stop the agent activity, but I'm going to say yes. And the moment I do that, it's actually asking to analyze the data. So I can press analyze the data, and the moment I ask for analyzing the data, it tells me to give me a file name for that. So I'm going to say task analyze, and the file name is going to be demo. And question: so how many planning and programming tasks are there above? So this is the question, and you can see that it is actually listing all the types of requests that is available, and it is actually sending me back that there are 3 planning tasks and 7 programming tasks mentioned above. The planning tasks, and it is listing the planning tasks, and also it is listing the code generation task. And again, the question whether you want to continue or no, it's coming. So I am going to say yes. The moment I do that, it's now asking me that it can generate code. So you can see that it's ready to generate code. The moment I click on generate code, it's going to ask in which kind of file name that it can save the code generated. So I'm going to say code my task, code my demo. So this is going to be the prefix of the Python files that it is going to write. So I'm going to say yes, and the moment I do that, it starts actually generating the code, and also it starts writing the generated code to the files. And now it has completed it. It has seen some couple of places where it can generate code, and now if I say yes, you'll see that it has not got any more tasks to do. All the tasks have been completed. And if I have only one option right now, that is to cancel, and once I do cancel, the process ends. If I go back to VS Code, and if I go into the folder where I have been working on, you'll see that I have a couple of additional code files here. So if I click on demo 6, you'll see that the plotting code has been written for me. And if I click on code demo 9, you'll see that another one matplotlib for creating the line plot has been created. And if I click on demo 16, you'll see that it is reading the CSV files and it is getting ready to render the data frame. So all these things have been done. But now I asked for a Streamlit app. Whatever the agent has given me is not a Streamlit app. It's a simple Python application. So whatever output I've got here is not perfect, as I already told. But the idea that I wanted to share here is that it can actually generate code and it can actually write it. But it is all done not just by the large language models. It is done with the help of the Python code. So what I'm going to do is I'm going to show you right now the Python code that is behind all the steps of the agent that you saw right now. This simple agent demo is what is powering all the tasks that you saw right now. and I am going to walk through this code at a rapid pace because there are lots of things to cover. Most of these things that I'm covering right now, I have covered it in the earlier videos, as I already told you. So this is kind of a cumulative video where I bring all the knowledge of Jinja templating, working on prompts and trying to solve the tasks, and using the programming logic to get the data out from the LLMs and using it to complete the tasks. So all these things I'll be right now completing in this video. So to begin with, these are the various modules that I'll be working with. Questionnaire is one of the interesting modules that I came across, library that I came across for asking the inputs. So the good looking input that you find here, the color variation and the choices, etc., that is through questionnaire. Let's proceed. I have got the Jinja template environment and the classes, and I have got a logger also, which actually logs the errors and as well as the comments that I want to share with the user. It also logs the data that is getting processed. All those stuff is done through this logging option. I am using the model used Echo and model used Super. So there are two models that I plan to use, but most of this code is written using GPT 3.5 Turbo. I did not use GPT-4 even for this demo. What I mean to say is that it's not that you need to use GPT, the best model available in the market. You can try with any model that you have, and this agent that you are running anyway is not controlled by the output of the large language model. It is controlled by the programming logic, as you saw. So let us proceed. Let me go with the flow of the code. So these are the various system prompts that I have already coded into the script, where the architect system message, the spec writer system message, tech lead system message, the full stack dev system message, task sorting, data analyst, and coding expert, all these system messages have been coded here and kept ready. In most of the agents that I come across, these prompts are kept in a separate file, and it is loaded from there. And when such a file is kept separately and it is getting loaded, it actually creates kind of a gap between the understanding. So I felt that having these things in a single file can make a huge difference. So here is where the Jinja environment is getting instantiated, and this total token is a global variable that I'm used for keeping track of the number of tokens that is used. If you go back here, if you see that by the end of every call, you can see how many tokens have been used. So this is possible because of these tokens. I'm also having some helper functions for the Jinja templating environment, and this LLM call OpenAI function is actually the agent that you guys are interacting with. In fact, it's not an agent, it's a LLM API endpoint, right? And to us, it becomes an agent because of the system message and the user message. And the system message and the user messages are built with the help of Jinja templating engine. You can see the token used comes from this particular line. The token usage is retrieved from the API response from OpenAI. So it's not something that I have tried to extract from tick token. I have done it through the API itself directly. So that's one of the neat things that I recently came across. These two supporting functions are going to read the file and write to the file. Both are actually reading and writing to the JSON files. This is another one point that I wanted to highlight. In most of the agents that I came across, the data is written to the SQLite database or Postgres database. And most of us who is coming into the agent programming are not that much familiar with the databases and how they work. So I felt, okay, it's better to actually have something that we can directly view. JSON files are easy to view and you can easily manipulate them also. So for an example, if I open this JSON file and if I render it, you can easily see what are the various keys and what are the values of it. Here I have zoomed in, so you are not able to see that, but you get the idea. So inside the database, having a look at looking at the database like this is a little bit tough. Yes, I agree. Working with the JSON file is a nightmare, but once you are comfortable with manipulating the JSON file, working with the database will be far more easier. Fine. So I have given you the introduction of the various functions that I am supporting functions that I have created. Next, what happens is I work with the available templates, that is the templates that is present inside the Jinja folder, this particular Jinja prompt folder. So there are various templates that I have already created for code extraction, data analysis, feature plan, simple code generator, specs, and task classifying. So all these agents I have already created. Sorry, all these prompts have been already created. So if you go into any of the prompts and if you read it, you will clearly understand that the prompts are actually giving the agent the ability to decide, the ability to get creative and give you the task list, or ability to find solution to the problems or write code. Everything is provided by these prompts, and these prompts are right now the Jinja templates into which your task and not just task, into which your variables that you have it in your Python environment can be placed. So that is how the prompts are making the agent to do wonders. Let's proceed further. I'm going with the flow. I would suggest that you guys take this particular code and start tweaking that. That is one of the main objective of creating this code. Yes, there are lots of open source agents already available, but they have their own level of abstraction on top of all the agent code. So that is something that made it difficult for me to explore agentic software. So this is one of the ways that you can try to explore. Let's proceed further. So these are the tasks that I have right now created in this particular agent demo, and the agent starts by asking the tasks. It classifies the tasks, it analyzes the data, generates code, and then finally gets out of the loop. And here is where the while loop starts. Most of the agents have this continuous execution format. So here I have just used a while loop. In other cases, there can be threads. There can be a way of continuously being online using Flask app or a Fast API backend. So there are various ways to keep the agent alive and continuously be available for you to ping and start getting the data. And another one way is to save the state of the agent. That I came across in Devika AI, and also I think they are doing that in GPT-Pilot also. So all this saving state, keeping the agent live, is all done through, some mechanism of loops. It may not be straightforward if you guys are new to programming, but yeah, this while true is going to keep the agent alive until I create a way to break it. Next comes the important step. Here, this choose task is going to continuously run whenever this loop is going to start, and it is going to give me all these choices, right? It is going to ask me what is the choice that you want to start working on. As per the agent process, the simple demo agent process, I need to first of all get the task. Here I start by ask tasks task, and then once the ask task is equal to the choose task, then what happens is the file name, the app type, the app name, and the prompt, all of these things are prompted from the user. After that, the context is getting created. This context is then sent to the load render template, and the specs prompt is used for getting the task specification. So if you go to the specs prompt, I'm going to dive into the prompts a bit later. I would suggest you guys to directly start exploring. So here I'm giving the app type, name, and the prompt, and all these things will come from the context that I am creating. And once that is done, the specs prompt tells that think step by step about the description of these things, and ask for additional questions, get the user stories, get the step by step process that you need to do for completing the objective. So all these things are provided in this particular prompt. So that's how this particular area, this leg of the code is going to render the tasks. Once the task has been created, then what happens is, once the prompt has been created, then we call the LLM through the LLM call OpenAI function. So we give the spec writer system message, we give the rendered prompt, that is this rendered prompt, and then we use the economy model. After that, we get the tasks. We get the tasks in response key, and we are going to split the task. So this is where the splitting happens. It happens by splitting with the new line character, and each line of the response from the OpenAI API is converted to a task. But here I have a basic mechanism to check whether the tasks have been given. If the task is less than 2 numbers, meaning there is something wrong in the task response. So I can literally tell that, and I can stop the process by there itself. But till now, when I tested, such a scenario did not happen. I tested almost some 10 to 15 different apps, and the tasks were always provided. So in that sense, the initial setup of getting the idea from the large language model for a particular problem or a particular app is very, very strong. After that, the context is updated with the tasks. I mean this context. This context is updated with the tasks, and then I am writing the context itself to the file name, the file name that I got here, where I store the output of the large language model response. So that's how I use the JSON file. After that, I do this thing. I actually pop the task. So I no longer keep the ask tasks in this particular list. So once the task is completed, I'm going to remove it from the list. So in this way, the agent will not do the same task again, or even you will not be able to select the task again. Once the task has been created, then comes the next task, that is class_tasks. So in this case, basically I'm classifying the tasks, and the same process continues. In the only difference is that I am going to reload the file, the JSON file that I created in this place. I'm going to reload it, and I'm going to use the tasks that is present in that. And then I'm going to use look into the tasks, and I'm going to classify it. And for classifying, I will be using text classifying prompt. You can take a look at the like the specs_specs.prompt. There is text classifying prompt under Jinja_template folder. You can take a look at that. The same thing is sent to the OpenAI LLM, and the classification is updated here. The classification is updated under task_class key, and then it is written back to a new file. So I create a new file called file task classified, and then I write the data into that file. I don't reuse this file because the data that is inside this file has to be safeguarded, because if there is something going wrong in the downstream, I don't want the upstream file to be lost. So that's why I use this way of safeguarding the file. And then I write the responses, and then again I pop the class tasks task. So that's done. Next, after the classification is done, I immediately write the generate code. Generate code also does the same thing, but only difference is that in case of generate code, it's going to retrieve the tasks, and it is going to start generating code for each of the tasks. But before it generates, it's going to check whether the task is of type code generation or it's of type problem solving. If it is not the case, then it will not generate code. It will actually skip it. That's why you see in our case, we only got 3 scripts, but there were lots of other tasks that is already present, but we only got 3. That's the reason for that. The process of sending the prompt and getting the data from the LLM is same. Only thing is I'm writing the data to the Python script here. In the other cases or other tasks, I am actually writing it to the JSON file, but in this case I am writing it to a Python file, and the Python file is kept in the same path. Also, I have an additional task where I analyze the data, meaning I update the information for of the tasks to the large language model through this particular task, and I ask the large language model to analyze the tasks and let me know and answer the questions that I ask it. So the questions like how many tasks are for coding, how many tasks are for planning, how many tasks for decision making, or what kind of tasks are present. You can ask any of these questions. So such a scenario you can solve using this particular leg of the script. Moving forward, after that analysis is completed, the analysis is stored back into the file, and it is stored under file task analyzed file data. After all the task has been completed, now the final task for choosing the cancel comes in, and if such a task of cancel is chosen, the loop is broken, and once the loop is broken, the code exits. Also, in every loop, this particular confirmation also is asked, whether do you have more questions and do you want to continue. So in case if any of the time if you say no for the this particular question, immediately this loop also will get broken. So in this way, what happens is the agent does not stay in endless loop, or else if you don't give such kind of a breaking options, then it stays in endless loop. Even if you use Control-C or Control-D, the loop does not break. So these are the challenges that I have come across, and I felt that we can actually look into creating agents and keep learning and keep developing new softwares. So just to recollect what we have learned till now. So we have learned about the various tasks that are required to solve a particular objective. And the objective that we planned was to create a Streamlit app that can read a CSV file, render it as a data frame, and then create bar charts and scatter plots and line plots, etc. For that, we had to work with all these kinds of tasks to begin with, and also we generated code at the end and we saved it to the Python files. We generated tasks, processed it, classified it, and stored them in the respective JSON file. And we did all of these things with the help of the large language model API endpoint from OpenAI, as well as with the help of Jinja templating language. So I believe that this actually provides a very good base on how the agents are working. So many of you might have been in confusion that how the agents are working in the front end and the back end. But after this video, you must have got a full clarity on what's actually powering agents, and how the agents are in endless loop, and how they keep solving the tasks and giving you good code that automates your work and speeds up your day-to-day activity. So do take a look and do practice. That's very important. That's how you can master this technology. Once you look at the data, once you see how the data is flowing into the prompt templates, into the large language models through the API endpoint, with the help of user and system prompts, experimenting with these things will provide you more avenue to get good output for code, as well as for generating the task steps that is required for the agents. You may not actually come up with the great perfect agent in the beginning. It takes a lot of effort to work with the prompts, to work with the various conditional mechanism to safeguard the output, as well as to get the objective that you want. So all these things takes a lot of practice and lots of work and lots of team effort too. In this case, I had to do it on my own, but if there is going to be multiple members in your team, then this is going to be way more faster and easier also. With these recap, I believe that you have learned a thing or two from this discussion. Do leave a like, and if you have any comments or questions, do leave the comment in the comment section. The code of this particular demo will be shared with you guys in the GitHub repo. You can take a look at that, and do subscribe to my channel for further updates. With that said, I would like to leave with 4 words, that is practice, practice, explore, explore. See you guys. Have a great time.